So far, we've learned how to run and manage Docker containers. We've also learned how we can find images on Docker Hub. In this lesson, we'll find a base image to start from and then build our own image. Any Docker image can be used as a base image, so choosing a base image to start from depends on what you want to build into your container. For example, if you're containerizing a Java web application, it would make sense to use the official Tomcat image as your base and add your application on top. In other cases, you might just want to use one of the Linux distribution images and build everything on top. For this lesson, we'll use the popular Alpine Linux distribution. Alpine Linux is a minimal Linux distribution that's great for making lightweight containers. We could use Docker Hub's search functionality to find the Alpine Linux image, or we can use the docker search command. Let's try it out. Now here's a list of the top Alpine Linux images on Docker Hub. The output of this command is quite similar to the Docker Hub search results, which shows the image name, whether or not the image is official, and the number of stars. It looks like there's an official Alpine Linux image simply named Alpine. Let's use the docker images command to list the images we have available on our Docker host. We have a couple of images locally, but no Alpine Linux. We can download Alpine Linux by using the docker pull command. We now have the Alpine Linux image locally on our Docker host. We can now verify this by once again running docker images. There's our Alpine Linux image. We can now begin creating our Docker image. There are two methods for creating a Docker image. The first is to create an image from a running container, which we'll do in this lesson. The second is to create the image programmatically using a file called a Dockerfile. Dockerfile image creation is the preferred method because the image creation can be versioned and reproduced. Let's create a simple containerized JavaScript application using the Node.js JavaScript runtime. The first thing we'll need for our image is Node.js, as the base Alpine image does not have it installed. Let's start an interactive session in a container created from the Alpine Linux image. Now we're inside the Alpine Linux Docker container. Alpine Linux's package manager is called APK, which we first need to update using the APK update command. Now that we've updated our package manager, we can now install Node.js. Now that the installation is complete, we can verify that we've installed the Node.js runtime using node-version. We now have Node installed, and so we can create our JavaScript application. Our simple Node application will take a series of numbers as arguments and return the average. Let's create a directory for our Node script. Now let's paste our Node script into a file called average.js. As you can see here, we sum the arguments and then divide it by the count, giving us the average. Let's test out our application real fast before we create our image. Our program works as expected. The average of 3, 4, and 5 is 4. We can now commit changes to our running container, which will create a new image that contains our new directory and JavaScript file. To commit changes from a container, we need the container ID. Remember, the container's internal hostname is the container ID, so we can get our ID by simply typing hostname. Now let's copy that to our clipboard and commit our changes. To commit our changes to the container, we can use the docker commit command. Docker commit accepts a few flags, one of which is the -m flag, which allows us to set a commit message for the commit. After the commit is complete, we see a new image ID, and we have just created our first Docker image. We can now test it out by using docker run with our new image ID. And once again, the average of 3, 4, and 5 is 4, so our containerized application works. There's a number of problems with this approach to building images, though. First, we can't easily specify our Node application as the default entry point or command for our container. This means that we had to know and care about the name of our average program, as well as its location on the container's file system. Secondly, there is no artifact that describes how this image was created. Infrastructure as code gives us visibility to the internals of our servers and the ability to easily change and test our infrastructure like we would normal software. This applies to Docker images as well. We can turn the creation of Docker images into code using a file known as the Dockerfile.